So, good day everyone. This is CEsolves and ang topic natin for today is resultant of forces and components, specifically how to find magnitude and direction of the resultant force. So, may dalawa tayo ditong problems which is this one and may tig-prepare akong summary ng formulas para ma-solve natin tong problems na to. Hindi ko muna siya explain pero I'll explain it using the problems na tig-prepare. So, yan. Sa first problem natin is replace the three forces by a single equivalent R. Express your answer in vector form. So, ang sabi dito is replace the three forces, meaning hanapin lang naman natin yung resultant force ng tatlong forces na to and express natin siya sa vector form which is IJK na form, which is ma-explain ko sa inyo mamaya. So, yan. Hanapin natin yung sa F1 muna, yung sa first force. So, F1. Hanapin natin yung X and Y components niya, which is this one. This one is the F1X. And this one is the F1Y. So, hanapin natin yan, yung components niya. So, F1X and F1Y. So, tingnan natin sa formula kung anong dapat na gamitin natin. Dito, which is, ang angle niya is with respect to the x-axis. So, hanapin natin siya dito. Formulas for solving x and y components of a force. Angle with respect to x-axis. So, ito yung gagamitin natin na formula para mahanap natin yung x and y components ng force. So, ito yung formula which is fx is equal to f cosine theta x. Sulatin natin dito. F cosine theta x. And fy is f sine theta x to. Theta x. Sorry. Yan. Copy natin. F sine theta x. So, yan. Ang gawin na lang natin is substitute natin tong values na to sa formula natin. So, since ang gamit natin dito is F1, ito yung magnitude niya which is 25 kilonewton. So, ito yung F natin. So, sulat natin 25 cosine theta x will be 45 degrees. And sa Fy naman is magiging 25 which is the magnitude sine theta x which is 45 degrees. So, solve natin siya sa calculator. Magiging 25 cosine 45 will be 17.68 kilonewtons. And sa F1y will be 25 sine 45. It will be 17.68 kilonewtons din. And kung papansin nyo, since nasa quadrant 1 tong force na to, nasa quadrant 1, meaning positive ang x component and positive din ang y component. So, positive ang values na makukuha natin. So, move on tayo sa F2. So, at F2, nasa fourth quadrant siya, nandito. So, yan. And mapapansin natin na ang angle is with respect to x. So, same formula lang na gagamitin natin sa F1. So, F2x is equal to f cosine theta x and F2y will be f cosine theta y. So, ang magnitude ng dito ng force 2 is 40 kilonewton. So, 40 cosine theta x is 60 degrees. 60 degrees. So, dito naman sa F2y will be 40. This is sine, sine and theta x. 40 sine theta x is 60 degrees. Equate natin yan sa calculator, magiging 40 cosine 60, 20 kilonewtons. And 40 sine 60 is 34.64 kilonewtons. 34.64 kilonewtons. So, yan. Nahanap na natin yung x and y component ng F2. And since nasa quadrant 4 siya, meaning Ang x component niya, positive. So, positive, tama to. And ang y component niya will be negative. So, lagyan natin ng negative sign. Kasi, pababa siya. And ang positive should be upward, kagaya nung sa F1. So, yan. Solve naman natin yung F3 at F3. Since nasa x-axis lang siya, wala siyang value ng y-axis. So, F3x lang ang meron niya. So, F3x will be negative 30 kilonewtons. Since, di ba ang positive natin should be to the right. Since ito to the left, magiging negative ang value ng ng F3x. So, F3y will be 0. Since nasa x-axis siya. So, ngayon, nahanap na natin yung F1 and F2, F3 na x and y components. So, i-add up natin siya para mahanap natin yung resultant x components and resultant y components. Which is, i-add lang naman natin yung x components ng lahat and yung y components ng lahat. So, unahin muna natin yung at Rx is equal to 17.68 plus 20 plus negative 30. So, add natin yan. 17.68 plus 20 plus negative 30. So, ang answer is 7.68. 7.68 kilonewtons. And ang Ry naman natin is 17.68 minus 34.64 and plus 0. So, solve natin yan. 17.68 minus 34.64 plus 0. So, ang Ry natin is negative 16.96 kilonewtons. So, yan. Nahanap na natin yung x and y components ng resultant resultant force. Ang gagawin natin ngayon is, di ba ang sabi sa problem, express your answer in vector form. So, yung x components, which is the Rx, siya yung may I sa hulihan, and yung y component, which is negative 16.96, is yung may j sa hulihan. Since yung x component, siya yung may I, and yung y component, siya yung may j na representation. So, isulat natin siya as that, as the vector form. So, magiging siyang R is equal to 7.68 I minus 16.96 J. So, yan na yung answer natin in vector form. Nakuha na natin yung hinahanap sa problem. Ay, wag na natin kalimutan pala yung unit. So, kilonewtons siya. So, yan na yung vector form. Pero, kung gusto natin malaman yung magnitude and direction, nasolve naman natin siya, pero kung gusto lang natin malaman, yan, gamitin natin yung formula na ito. Formulas for finding the magnitude and direction. So, ito represents the magnitude of F, and yan yung niya, and ito din yung angle. So, yan. Just for the sake na malaman natin yung magnitude and direction. So, the magnitude of F is equal to fx squared, the square root of fx squared plus fy squared. Fx squared plus fy squared. So, yan. Square root of fx squared, palitan na tuloy natin yan ng R kasi ang ginamit nating letter is R, which is the resultant. So, R. So, Rx squared is 7.68 squared plus negative 16.96 squared. Negative 16.96 squared. So, yan. Solve natin siya sa calculator. Magiging 7.68 squared plus the quantity negative 16.96 squared. So, ang magnitude natin will be 18.62 kilonewtons. 18.62 kilonewtons. And yung para mahanap naman natin yung direction, which is this one, the theta, ang magiging solution is tan negative 1 inverse tan fy over fx. So, ry over rx yan. Tan negative 1 ry over rx. So, inverse tan of ry will be negative 16 point, or huwag na naman natin isali yung negative. So, 16.96 all over 7.68 equal to, magiging sagot dyan will be tan of 16.96 over 7.68, 65.64 degrees. So yan, nakuha natin ito yung magnitude at ito yung direction. So yan na yun. Ito yung answer in vector form. Wait, markan ko tuloy. Ito yung answer in vector form, yung may I and J, which means yung Rx, yung X component siya yung katabi ng I, and yung Y component siya yung katabi ng J. So ito din yun, magnitude. At ito yung direction. So yan, nasagutan na natin. Ngayon is move on tayo sa second problem. So ngayon, next problem is two men are trying to roll the boulder by applying the forces shown. Determine the magnitude and direction of the force that is equivalent to the two applied forces. So, in other words, may dalawang lalaki daw na nag-try na mag-roll ng boulder na nag-apply sila ng force, which is itong first person and second person, tipo pull. And ito yung parang pinupush niya yung rock. So, iti-determine natin yung magnitude and direction. Yan. Magnitude and direction of the force ng dalawang ina-exert ng dalawang tao na to. So, yan. I-draw muna natin siya kagaya nito. So, para mas maintindihan natin yung graph. So, yan. Draw muna natin. Ito yung magiging y-axis at ito yung magiging x-axis. So, itong force muna na tong isulat natin. So, yan, magiging siyang, may angle siya na 70 degrees. So, 70 degrees siya. And, ang magnitude niya is 1,335 newtons. And ito, may angle siyang 20 degrees and 667 newtons. So, 20 degrees siya dito. Ay, ibang color ko na tuloy para wag tayo masyado malito. Yan. Tapos, 667 newtons. 667 newtons and 20 degrees. So, yan. Solve natin siya. Erase ko na tong mga extra. Lahat sila nasa quadrant 1, which is lahat ng x components and y components are positive. Since lahat ng mga nila, ang mga x component papunta sa right, which is positive, and y component papunta sa taas, which is positive din. So, solve muna natin. I-let us, natin to. Wait, hanap tayo ng ibang color. Yan, ito yung F1 at ito yung F2. Yan, F1 muna tayo at F1. So, F1x and F1y. Since ang angle niya is 70 degrees and with respect to the x-axis, ang gagamitin lang natin is ito pa rin. So, same formula. So, F cosine theta x and F sine theta x. So, equate natin yan. F will be 1,335 cosine theta x is 70. Same with this, 1,335 sine theta x is 70 degrees. So, solve natin siya sa calculator. 1,335 cosine theta x, 70. So, 456.6 newtons. And sine ng 1,335 sine 70 is 1,254.5 newtons. So yan, nahanap na natin yung x and y components. So sa ano naman tayo, F2. So F2x and F2y is equal to F cosine theta x and F sine theta x. Since yan, ang 20 degrees angle lang din siya sa sa x-axis. So same formula lang gagamitin natin. So magnitude na given is 667 newtons. Cosine theta x is 20 and dito naman 667 sine 20. So solve natin siya, magiging 667 cosine 20 will be 626.8 newtons and 667 sine 20 will be 228.1 newtons. So same lang, add natin yung x components and yung y components. So sa x components muna tayo, which is this one. So para mahanap natin yung Rx. So Rx will be 456.6 plus 626.8. So add natin siya. 456.6 plus 626.8. Magiging siyang 1,083.4. 1,083.4 newtons. And Ry natin will be this two. Yung mga y components ng dalawang forces. So 1,254.5 plus 228.1. So 0.5 plus 228.1. So 1,482.6 newtons. So ngayon, para mahanap natin yung magnitude, which is hinahanap dito, so R will be, magnitude ng R will be Rx squared plus Ry squared. So yan. Rx natin will be 1,083.4 squared plus Ry is 1,482.6 squared. So yan. I-solve natin siya sa calculator. 1,083.4 squared plus 1,482.6 squared. So yan, ang magnitude natin will be equal to 1,836.3 newtons. So check natin kung tama. Yes, tama tayo. So yan yung yung magnitude natin. So box lang natin. Ngayon, hanapin naman natin yung yung direction. Erase ko lang to. Yung direction naman. So, direction natin, yung formula natin is ito, which is inverse tan of Ry over Rx. So, inverse tan of Ry over Rx. So, tan. So, Ry natin is 1,482.6 over 1,083.4. So, yan. Input natin yan sa calculator. Ang answer is 1,482.6 over 1,083.4. 53.84 degrees. So, yan na yung natin, yung direction. So, mark lang natin. Ito yung magnitude. At ito yung direction ng resultant force natin. So, yan. Yun lang naman yung dalawang problems so far. And sana naintindihan nyo and thank you guys for watching. I'll be uploading more problems soon. Bye-bye!